Welcome guys to part 2 of equation of motion along a straight line. In part 1 we have understood different terms which are very useful to understand the equations of motion. That is, we understood what is the difference between distance and displacement, speed and velocity, what is uniform motion, non-uniform motion, what is acceleration and what are the different types of acceleration. In this video, we will understand distance time graph and velocity time graphs and what all information we can fetch through these graphs. So let's start with distance time graph. That is, the motion means the change in position of the object with time that can be represented on a distance time graph. Let's first consider the uniform motion case. Now uniform motion, we know velocity remains constant with time or the change in velocity is 0. Consider now this case, a table here where the time is increasing by half hour and accordingly the distance is also continuously increasing by 20 kilometers. So if a object is going from position A to position B, but then it is covering equal distance, say 20 kilometers for every half hour. For each half hour it is covering 20 kilometers. Like this. Then it is said to be in uniform motion where the velocity remains constant with time and the change in velocity is 0. Now, if this is the case, if we plot a graph of distance versus time, it will be a straight line graph having a slope because with time the distance is continuously increasing. Through this graph, we can find the velocity of the vehicle or the object. Suppose we want to find the velocity of the object in this time interval t2 minus t1. So within this time interval t2 minus t1, how much is the velocity? So for that we need to know what is the distance it has covered during this time interval. So we know speed is equal to total distance traveled upon total time required. So in this time duration t2 minus t1, total distance travel is s2 minus s1. So we can have slope of the graph. Now slope of the graph is what? It is y2 minus y1 upon x2 minus x1. And what are y2, y1 or x2, x1? These are the coordinates of this point. For point B, x coordinate is t2. So I will write this t2 and y coordinate is s2 like this. So for point A, x coordinate is t1 and y coordinate is s1. So when we want to find the slope of the graph, we take y2, this becomes your y2, this becomes your x2 and this is x1 and this is y1. So y2 minus y1, that is s2 minus s1 upon t2 minus t1. So this slope will give us the velocity because total distance traveled between this time interval is s2 minus s1 upon time required is t2 minus t1. So slope of this graph will give us the velocity of the object. So distance time graph will help us to find the velocity of the object. Now this graph was for uniform motion. So uniform motion will always give a straight line graph with a slope. It will always have a slope. Now next is distance time graph for non-uniform motion. Non-uniform motion means unequal distances in equal intervals of time. So here half hour we are considering the time interval and the distance covered here initially is 14 kilometers, then 13 kilometers, then it is 14 kilometers and here 15 kilometers. So here it is traveling unequal distances in equal intervals of time. So in such cases the graph is not a straight line graph. It will be a curved line graph or we say a non-linear graph, because the distance covered is not same for equal intervals of time. Such cases we say it is non-linear graph or a curved line graph for non-uniform motion. Now next is velocity time graph. We have seen now distance time graph. Now we'll understand what is velocity time graph for uniform velocity. For uniform velocity, once again, uniform velocity means the velocity remains constant with time or change in velocity is zero. Now when the velocity is uniform, that means body is or the object is continuously traveling with same velocity irrespective of time. So for first 1 hour it is maintaining same velocity, that is 40 kilometers per hour. Next 1 hour also it is maintaining same velocity, and so on. So its velocity is constant. The change in velocity is zero, and in such case the acceleration will be zero because the final velocity and initial velocity are same. So your numerator becomes 0. So this becomes acceleration to be 0. Now here the slope is a zero slope graph because this velocity is maintaining constant and it becomes parallel to the x-axis. So it is horizontal straight line parallel to the x-axis. So it is zero slope graph. It will not have any slope. So in such case we say that acceleration is 0. However, now if you want to find the distance as we know it is distance or displacement is velocity into time. So how much, for which region you want to find the distance. Say if we want to find the distance travel from time t2, in between time t2 and t1. So this region is the distance that it has traveled. So how do we find this region? We find the area of this region. Area is what now in this case, because it is a rectangle, so area is length into this breadth. Okay, so length is what? T2 minus T1 into this breadth is same 40 kilometers per hour. So that will give us the distance or displacement that is equal to the area enclosed by velocity time graph. So you need to know for what time interval you want to find the distance covered. So in this case, if we are finding the distance covered between T2 and T1, then accordingly we have to select that region, and this comes out to be a quadrilateral. So area of quadrilateral is length into breadth, and that will give us the distance or displacement. So velocity time graph will always give us the distance or displacement of the object. Now this was for uniform velocity. Now let's understand velocity time graph for uniform acceleration. Uniform acceleration means velocity either increases or decreases by equal amounts in equal intervals of time. So that is uniform acceleration. Now here velocity is increasing in equal intervals of time. There is equal amount of increase in velocity in equal intervals of time. Here 1 minute velocity is changing by 4 meters per second. Another 1 minute it is changing by 4 meters per second. Another 1 minute it is changing by 4 meters per second. So here it is a uniform acceleration. The velocity is increasing. In this case it is increasing. It can either be decreasing also. So here uniform acceleration velocity increases by equal amounts in equal intervals of time. Now in such case the line of the graph is straight and it has got a slope. Whereas earlier case the line had no slope. It was a straight line parallel to the x-axis. This is uniform acceleration. So uniform acceleration, there is a slope to the line. Now through this also we can find the distance, how much distance it has covered in certain time period. Say if we want to find how much distance it has covered in between 2 seconds and 4 seconds. So here this is the region. So area under this region will give us the distance. Okay. So now this becomes a trapezium. So area of the trapezium, if we are able to find, we can find the distance of the distance covered by the object. Now velocity, as we know, is equal to displacement into time. So velocity into time will give us the displacement. That is the area enclosed by the velocity time graph. Now, as I said, velocity here is increasing, but velocity can be decreasing also. So with time the velocity is continuously decreasing. So this is a negative acceleration, we can say, or it is also called as retardation or deceleration. This was all for uniform acceleration. We also have non-uniform accelerated motion, where the velocity time graph can have any shape depending on how the acceleration changes with time. So any shape depending upon how the acceleration changes. So initially for first few minutes the velocity has increased with time. Say for next few minutes the velocity is decreasing with time. Now for another few minutes the velocity is increasing with time. So now this becomes a non-uniform accelerated motion, where the velocity is not having the same pattern. It is increasing, decreasing, or there is unequal amount of increase and decrease with equal intervals of time. This becomes non-uniform accelerated motion. So that's all in this video. In the next video, we will understand all the three equations of motion and derive them using the line graphs. But before that, be thorough with the first two videos. So that's all for this. Do like, share, subscribe and hit the bell icon for more such videos. Thank you.